So we have very few questions to go through, but keep them coming in the chat window and I'll try to get them all out. Our first question was from Gavin. I think it's directed to Jennifer, but I think multiple speakers can probably answer to this. Gavin asked, on the ISS, each crew member is given basic training and understanding of each member's specialty. So everyone has basic engineering knowledge in case the crew member expert is not around to solve certain issues. Would Artemis astronauts therefore need to have the same amount of expertise and knowledge of each instrument that will be used during EVAs, or will each be more proficient in different instruments?
Well, I suppose that everyone can weigh in. That's a general question. I think it was touched upon in many of the talks. I think it's important to go through these types of questions by doing high fidelity sims and testing, right? Probably you're going to have, at least in the beginning, a small number of crew. So those folks should know how to use those instruments in case one breaks, in case tasks get reallocated. We've seen examples where we have to replan, and maybe one crew member will be doing something they weren't originally planning to do. And so to maintain that amount of flexibility, the crew member should be versed in the utilization of, we're going to have handheld instruments, different types of sample collection containers, especially going to the poles where you're looking for volatiles. If we're able to get containers that can return samples at cryogenic temperatures, that can be hermetically sealed so we don't lose any of those volatiles. How do you actually do that? How do you collect those samples? It's probably going to be a little more complicated too, because one of the things that we highlighted in the Artemis SDT, the Science Definition Team report, was that especially for volatiles, and since we're talking about the South Polar region, we want to have concurrent in situ measurements while we're collecting those volatile samples. And Renee talked about this morning too. And the reason for that is for the scientific integrity, but also because we don't fully understand the losses that will occur with those volatiles when you're collecting, when you're putting them in the containers, when they're being transported back, when they're in curation, when they're in the lab. And so we need to have that sort of ground truth to cross-correlate. So I think the operations will be relatively complex, but others should weigh in.
Well, I guess I would add that philosophically, this illustrates the important point that everybody kind of needs to be in the room for these type of discussions, which is actually what this workshop represents. So it's perfect. These types of questions come up, and some people actually may feel like they have an answer that they feel is robust, but it may be that answer doesn't consider an important factor that impacts some other part of the mission. And so if those types of questions are asked and discussed with people who represent different types of hardware instrumentation, the EDA community, the scientific community, then we'll close on a better and more refined answer. And of course, there will be a preliminary answer that you'll want to test in these field-based sims that everybody's discussing. And inevitably, you will realize in the midst of that sim that you forgot to ask a question, and you're going to find an answer or a set of answers that were completely unanticipated.
Yeah, Amanda, could I add to that briefly? Yeah, this is Jim Head. So I think that a couple of comments relevant to this is, first of all, the videos that we saw of the back room, the movies were really amazing. I mean, I'd never seen those before. I want to tell you that shirt I was wearing, my wife burned that a couple weeks after I got home. But anyway, the key here is that it sounds a lot more chaotic than it really was. I think, having the thing pan around, not seeing the overall picture, and getting all kinds of extraneous noise in there, which I don't remember at all, I think it was much more coherent than that would lead you to believe, okay? So that's one thing. The second thing is, I think, there's something really important here. Noah brought this up about the gravimeter, the traverse gravimeter. The reason that was a question was that a measurement had been made, which was really off, 3 sigma from a previous one that had been made, and there was a gradient between the two terrains. And so one of the things we'd actually simulated was that, and the decision was made that is so important, we need to go back and do that. So that's what that discussion was about. And a key point here is there are mission rules. a lot of us are so engaged in a mission that planning, et cetera, that you don't sit down to argue about priorities. You need to argue about priorities because, in fact, the traverse gravimeter would have a higher priority than potentially some of the geological investigations. That is established before the mission. For example, the heat flow experiment on Apollo 15 had the highest scientific priority. So when we couldn't get the drill out and couldn't put the probes in, that took priority over field geology. And that's why we lost part of the EVA. And it was a priority that had been previously established. So the point is, pay attention to that. You're going to have mission rules. You're going to have these priorities. Make sure you're at those meetings so you can properly represent it and then know them. So when these things happen, you don't cry about it, if you will. I mean, so yeah, so those are just a couple of points.
Those are great points. I think in extension to that, Alexander asks in the chat, in the Apollo video recordings that were shared today, there was a healthy tension between the surface crew and the mission control during exploration. So can someone talk about the fine line between accomplishing science goals versus deviating from the mission plan or direction from mission control? What is the key for managing that tension and making sure exploration is carried out in the most beneficial and efficient way? So very much in that vein.
So, Amanda, I guess maybe I can tie into what Jim was just saying there. And I think what Jim was just saying actually addresses somewhat its mission priorities. It's writing the stuff down ahead of time and knowing what you want to accomplish and how much time you want to spend trying to accomplish it both, I think. So I think those tie in very much to what this question is asking.
And I would just add to that, I think it's a dynamic tension. I think you're going to have that all the time. It's not, we'll be able to refer to the mission rules much more effectively than we were getting out the 6-inch thick book or et cetera. But there's always going to be that tension. And as I think Noah was saying, for example, with a gravimeter, okay, there were rules about how much difference there had to be to exert that priority. And that's part of the debate that was going on. You could hear that. It's off nominal. It's not quite. That's dynamic tension. Time was not wasted there. That was what was supposed to be going on. So you need to prepare for that. And like I said, I was part of a simulation. I was the actual astronaut in mission control who was playing the astronaut. And I introduced that, that difference. And, what are we going to do? And a decision was made to go back and do it. And in this case, in the real world, when it happened, it wasn't extensive enough to, as I remember it, to actually seriously modify it. But that's the way it works. Dynamic tension, that's the way it's going to be. And we should simulate and practice that.
Yeah, and that word simulate, I think, is actually key, Jim. I mean, one of the things that we found in our SIMs is you develop trust between the science ops supporting staff and the crew. And as that trust strengthens, those types of conflicts decrease. And so train is, of course, the mantra that you've spoken for many years. And I think that that's going to be key to minimizing those types of problems. They'll never go away completely, but SIMs can reduce that tension.
And just to illustrate how important the science and engineering synergism is, the simulation supervisors are the key people who ran the simulations. They put the things in that needed to be tested, okay? And, I work with those people. So myself and an engineer would go into the basement of Mission Control, and, we would be the astronauts on the surface, okay? And we would introduce like various things. The sim sup would drop his hand on and I would kind of look at a rock and trip over it. Oh, I'm okay. But he would introduce a suit leak, okay? And all of a sudden, everybody in the suit area would go, oh, geez, we're losing power. And I'm going, I'm fine, no problem. And I knew they were doing that, and I would kind of like go off and do something else. But these are the kind of things that literally, so we work with the astronauts, we work with the simulation people, we work with the whole of mission control. So you practice. And one of the proudest things, one last thing, one of the proudest things I have out of the Apollo program was after doing a couple of these full-up simulations as the astronaut, I got an award from the ASPO office of being a half astronaut. Think about it.
Yeah,
So
just
that
along
again,
the lines of these, still along the lines of the real-time operations. So understood we did this in Apollo, and to an extent, we heard Ashton talk about Mars missions. But I want to point out that the Viper mission is doing this now. right? Because we have a rover and we are going to have real-time operations where we have a science team that is making tactical decisions based on that data that's coming back. And so we're having to, develop and optimize not only the data and visualization systems to make sense of that data, but also the entire comm and the whole architecture of the mission to enable this. And like David and James were saying, there's a tension, right, between the engineers and the mission systems folks who want to make it safe, and science who needs to get to the science objectives while staying in the box of the mission rules. So it's good that we are as we embark upon Artemis, we have missions that are sort of working in this sort of time framework.
And Jim brings up a really
These
critical point
situations
here.
are really
There's going to be robotic exploration contemporaneously with human exploration. They're going to be separate. So we have to work that interface too. That, it's going to be slightly different, but with each of the robotic and the human, but that they have to integrate too, because they're going to discover, like Jen's, the Viper mission, they're going to discover something that we want to go see. Okay, so how do we work that in? Can we work it into the Traverse, this one or the next one? It's another element that we need to pay attention to. Sorry, I'll shut up.
These are all great points. I'm really hoping that we can keep this up for our breakout discussions later. I have to pass it off to Jose, who's going to talk to us about how we're going to go about doing that.